partial derivatives implicitly. Find the del z, del x, and del z, del y, where xz plus yz plus xy equal to 0. And we have this one also, where this one is equal to what? It's equal to this. Don't forget that we have done implicit differentiation for multiple variable. So you can check that video. Some questions there. Okay. So but I want to teach us another way to solve it using a formula. Okay. I'm going to start from here. If you have 3 variables, okay, and what you do in this case is to bring all your equation to one side, to the left side, and equate it to what? To 0. What we are going to do here, no, don't forget that these 3 functions you're going to have here, this f subscript x, you're going to have f subscript y, f subscript z, and likewise also this one we're going to have z subscript x, z subscript y. But the first thing we want to do first, we want to differentiate with respect to x, okay, and that will be equal to what? Partial differential of f respect to x times del x, del what? Del x. So this one is what? Is 1. So plus del f, partial differential respect to y, del y, times del y, del what? Del x. Don't forget, the moment you are differentiating with respect to x, the other variable will be what? Will be constant. So in this case now, when we are differentiating respect to x now, the y is what? Is constant. So if you differentiate y respect to x, this will be 0. Okay, so it make everything here to what? To be 0. So then plus what? Plus del f, del what? Del z times del z, del what? Del x. Okay, equals what? Equal to 0. So this one is gone. This is equal to 0. This is gone. So we have here. So from there we can get del z, del x, and that will be equal to what? Del z, del x will be equal to, move this on to the other side, which is what? Which will be this. Don't forget that del f, del x is this. That's minus over what? Over what? Over del. So in a similar pattern, I'm going to show that one to us now. Okay, do the same thing also here. Differentiate implicitly respect to y. So we're going to have f del x times del x del y. And in this case now, when you are differentiating respect to y, x will be kept as constant. So this one will become what? It becomes 0. Okay, so all of this one is gone. So plus del f del y times your del y respect to what? Respect to itself. So this is 1 here, then plus del f del z times del z del what? Del y equal to 0. Then you can make this one the subjects. So if you do that, you have this. Move this one to other side. That will be this one, negative of this one, f subscript y over this one, f z. So we want to try to use formula. What we did before on this implicit differentiation is to differentiate the given equation respect to x and differentiate it also the given equation respect to y. Okay, but we want to try the formula method. I think it's a little bit faster and get the solution. Okay, so let's use that for this question. For this question, I've already told us that the old expression must be in one side and must be equal to 0. So therefore, if I'm looking for del, if I'm looking for this now, so there will not be y in your something. Okay, so then because when you're getting del z, del x, your y is constant. So let's apply that. Can you differentiate this one respect to implicitly? Let me get that implicitly. So this will be kept constant. This one also, this will be 0. There's no x here. Here, plus y. Can you also differentiate this one respect to z? Respect to z, you're going to have this. You keep this one, you differentiate this one alone, and keep this one constant. And z respect to z is 1. So you have this. Here, respect to z, You differentiate this one, so we have plus y. And finally, with respect to z, there is no z here. Everything here is 0. So this is faster. I'm going to do the two-way, the two-way. So it's not left for you to choose the one you want. Okay. Then the other one, del z, del y. In this case now, it's going to be minus this f subscript z. Any subscript of x in this case, because x is constant. So what are we doing there? It's very simple. Come back to your equation. Differentiate the given expression respect to y. There's no y here, so this is 0 in this case. Here, you're only differentiating y here. You keep this one constant, so you have z. Okay, here, you differentiate your y here. You keep your s constant. It's 1, so you have what? Plus this all over. Then now differentiate respect to z. Respect to z, I think we have it here. Another method, the normal method, the one I used previously on implicit differentiation, is to differentiate the given expression. Differentiate that z. I mean, that's your function. But you are differentiating it with respect to what? These two variables. So when you are differentiating with respect to x, implicitly, your y will be kept constant. So in that case now, we are going to have, in this case now, respect to x, this is going to involve two variables. If I differentiate the first one, I will have z, then plus. Then you keep the x constant and differentiate your z. Okay, and that will be del z, del x. The second one, you have your y, you have your z. So the y is just a constant. Equal to what? I'm keeping this one constant. I'm differentiating the z respect to. Okay, that one is done too. Then plus the xy. The y is a constant, so we're going to keep it constant and differentiate what? The x, which is 1, equal to what? Equal to 0. Then the next thing to do now is to factorize del z del x. If you factorize it, you're going to have x plus y. Then you can move these two to other side. What? Del z del x. And del x equal to what? Minus this all over x plus y. Okay, and that's what we got for the formula 1 using the formula approach. You're given the equation with respect to y, and in that case now, when you are differentiating with respect to y, your x will be what? Will be constant. So we're going to have now x is constant. I'm having this. That will be del z del what? Del y, then plus. This one will involve pull through, so that will be z times what? Times 1, then plus. Now keep your y constant and differentiate your z respect to y. Okay, then plus. Here also respect to y. This one is a constant. I'm differentiating y respect to itself. That's 1 equal to what? Equal to 0. Okay, can you factorize your this one? Factorize it, then we have this equal to minus this. Okay, which is same thing as del z del y is equal to minus this over what? Over x plus y. So if we check the formula we use, you can see negative outside, z plus x, and same as what? X plus z. They're the same thing. Okay, over what? Over x plus. That's another thing we have achieved in this place. To use both the formula method or use the normal approach to this solution. Determine which one is convenient for you. Okay. Actually, the question will not stipulate which way to go, but you're the one that will determine the one that suits you. The B part, I'm going to use the formula straight away for the B part. I'm going to use formula straight away. Del z del x is going to give me minus f subscript y over what? F subscript z. Okay, so let's the first thing we are going to do, we're going to move everything to one side, to the left side to do, which is now f is the functions of what? These three variables. F subscript y. This one is a constant, it doesn't have y, so you keep it like that. Then you differentiate your sign. The derivative of sine is cos. The derivative of sine is cos. One thing you are going to do here, this involves a chain rule. So times del of del y of that composite function. Especially the inner function respect to y, and that's what? That's 2. That's 2. And that gives us what? 2 times this. That's what we have for the f subscript y. What about f subscript z? Okay, for that, it's going to give us what? It's going to give us, this one also is going to be constant. Keep it constant. Then you differentiate this as cos. Derivative of the inner function times del z of the inner function. You differentiate this one, and that'll be what? Respect to z, that's minus. Then we can go back to our formula. Del z del x will be equal to minus. We have this f subscript y. We have this, that's that, all over f subscript z. But you can write your answer as this. If this negative come down, then we have, okay. So that's that on that case. Let's get the del z del y, and the formula is what? So the trick is this: if you are doing respect to y, the function respect to y, you ensure that there is no subscript of y in your formula again. Okay, it's going to start from minus f subscript x over what? F subscript z. Gotten value for f subscript z. Now we have that. What f subscript x? Do we have that? Not yet. Let's go back to that functions. So if you are doing respect to x, that means you are differentiating this one, exponential function. And don't forget that when you have exponential function, okay, respect to its function, it's going to give you the same function times the derivative of this function. So in this case, it's 1. So you're going to give this, and then you keep this one constant. Okay. This function, you don't have x variable there, so just a constant. And don't forget, we've already moved this one to the other side. Okay, and if you differentiate that, that's what? That's 0. Okay, so that's what we have there. So the final answer will just be equal to what? Will be equal to this minus this one. So that's what we have there. So, and if we like, we can write it as this form. Let the minus come down, and that will. So that's on that B part on that question. Okay. So please don't forget to, if you're watching for the first time, okay, quickly smash the watermarks and subscribe to the channel, so that anytime I upload, you get notified. Don't stop there. Click on like button and begin to type your comments. Okay. Finally, share the links of this video massively on all your social media platforms. Thank you for doing that.